Hello and welcome back to the REFramework training. Now that we've edited the config file, changed the type of the variable TransactionItem to DataRow, and added the workflows to open, close, and kill the applications used in the process, it's now time to dive into the GetTransactionData state. In this demo, we'll configure the GetTransactionData workflow to use a tabular data source by updating, adding, and deleting activities. Ready? Let's open the workflow. To begin with, let's take a look at the arguments. We've seen earlier the out_transaction_item is of QItem type. Of course, we need to change it to DataRow. As we know, our process isn't using orchestrator QItems, so we need to delete the existing GetTransactionItem activity. In addition to deleting, we must also set up the logic to retrieve transaction items from Excel. We'll complete these steps in a moment, so stay tuned. To support other types of data, REFramework has an argument named IO_transaction_data here in the GetTransactionData workflow. This argument is used to store the collection of data. After reading the data from a source file, such as an Excel file, the resulting data table gets stored in the argument IO_transaction_data. Are you wondering why the direction should be in/out? Because it's the output for the first run, and then it's the input for all of the other transactions. Now that we know what to configure, let's get to action. It's well known that REFramework has a built-in exception handling. Since we've already learned exception handling in REFramework in our previous course, it's easy to understand why the activities here are contained in retry scopes and try-catch blocks. Now let's delete the GetTransactionItem activity. We need some activities to read data from the source, right? So let's set up the logic to retrieve transaction items from Excel. To do so, let's use Workbook Read Range activity to read the spreadsheet from our Excel file. One thing to note here, when reading data from external sources that may fail, like a remote file or shared location, retry scope is needed. We could even consider deleting the retry scope for our use case as we're reading data from a local file. Here, we're not deleting the retry scope activity. Next, let's provide the path in_config, open brackets, open quotes, input file path, close quotes, close brackets, .toString. We need to read the entire sheet 1, so let's just remove the range for the activity and make sure that the Add Headers option is checked. Finally, the output will go to IO_transaction_data, as mentioned above. As we know, the GetTransaction workflow is executed for every transaction. Of course, we don't want to read the file every time. In this case, we want to read the source data only once, and then we fetch each row from IO_transaction_data as a transaction item. So how will it know if it's reading data for the first time? If it is the first time, the IO_transaction_data argument must hold nothing before reading the data. We'll add an if activity to check if the data source wasn't initialized and read with the condition that IO_transaction_data is nothing. If it wasn't initialized, then read the spreadsheet from the specified Excel file. One quick note here. As an alternative, the source data can be read at the beginning of the process in the init_all_settings workflow and stored as a collection of data in the variable dt_transaction_data. Just like how a configuration file is read and configured in the init_all_settings workflow. Okay, so what's next? We just read the data from the source. Well, we need to implement the logic to retrieve one row each time the GetTransactionData.xaml is executed. We need to implement the logic to retrieve one row each time. To do so, we'll add another if activity and rename it to if a new transaction is available. Are you wondering why we aren't adding this logic within the retry and try-catch blocks immediately after the read range activity? Indeed, both if and the assign inside it are working with the data which is already in the process memory, so there's no reason for it to fail from the external causes. Let's move forward now. We need to add a condition to determine if the in_transaction number is less than or equal to the number of rows from the transaction data. Here, transaction number starts with 1, and if we have one transaction data, then we need to process that one too. The condition is in_transaction number is less or equal to io_transaction_data.rows.count, which verifies whether there are rows left to process. In the then branch, we need to consider that for transaction number 1, we need to get the first row from the transaction data, which is index 0. This translates to transaction number -1. And for that, we add an assign activity to set the appropriate row to be the current transaction item. out_transaction_item equals io_transaction data, open brackets, in_transaction number -1, close brackets. So, the argument in_transaction number is used to track the row currently being processed. In the else branch, when we don't have any other transactions, we assign nothing to out_transaction_item to stop the processing. We can also leave the else branch empty, as the default value for a DataRow argument is nothing. As a side note, we could have used a for each row activity to read the data rows of our data table one by one. But we need to use the transaction number index to remember what transaction we processed. And it's precisely this that gives us the ability to retry a transaction by simply not incrementing the index. Okay, we're almost at the end. Now we need to set proper values for the transaction information fields, which, as we recall, are used to add log information. We already know that these log field variables will carry these values to the setTransactionStatus.xaml file. So, since transaction ID must be unique, let's leave it set to the current timestamp. If you do need to assign a specific value to this field, bear in mind that it should be a value to uniquely identify each transaction, and that it's used to link a log message to a transaction. Next, we have the transaction field 1 and transaction field 2, where we can have any additional details. We'll use transaction field 1 to add all of the other information. For our case, we'll concatenate the 3 values retrieved: cash in, on us check, and not on us check, with dashes between them. For example, this log field for our first transaction will look like this: open quotes log f_transaction field 1, close quotes, colon, open quotes 1-100-50, close quotes. You can also add the details to transaction field 2 as well. Great, we're all set. Let's save the GetTransactionData workflow. Okay, we're at the end of this demo where we've updated the GetTransactionData workflow to read the data from a local Excel file. Now is a good time to take a moment and review the business process, transaction data and process section of the REF without queue items checklist. After watching this video, could you say why we need to delete the GetTransactionItem activity? Where do we store the collection of transaction items? Why do we read the Excel file inside an if activity? What does the transaction number variable help us to do when working with tabular data? Now we're ready to dive into the process transaction state. Stay tuned to continue building our process in the next video. Thank you for watching, and until next time, happy automation!